Hello, students. Welcome to lesson 3 of this chapter, in which we have been solving trigonometric equations. In the first lesson, we laid the foundation for the whole process by talking about the inverse trigonometric functions, which is how we write the solution of an equation, right? If sine x equals half, then x is sine inverse of half. So we introduced the concept of inverse trigonometric functions through their graphs and their properties. In the second lesson, we solved basic trigonometric equation. Now, what is a basic equation? An equation which says something like cos x equals a number or tan x equals a number. Simple equation. The angle has not been modified. Maybe, sometimes the equation can be given in a standard form where you have to isolate that trigonometric ratio, but the angle was simple, x always. Okay. Now we are at the next stage where we will solve equations in which the angles are other than x. Like it could be 2x or half x. No, that is what we mean by multiple angle. Okay? Multiple angle does not mean different more than one angle. What it means is multiple of an angle. Okay. And what will be the process of solving? We will solve just like we solve the basic equations, which means we will try to isolate the trigonometric function to the left side and have a number on the right side. And then the next thing, let me actually summarize here. This is the summary of the previous lesson, okay? And we will use it in solving multiple angle equations. The summary was, one of the summaries I would say, from the previous lesson was, if sine x is equal to some known angle like sine theta, here x is a variable like the solution and theta is a particular value, okay? Like if I say sine x equals half, that half can be written as, let me demonstrate with example, okay? So it's not confusing. If sine x is half, that half can be written as sine pi over 6, right? That pi over 6 is like the theta here, okay? Known value. So now with that understanding, if sine x is equal to sine theta, then the two basic solutions in the range, 0 to 2 pi, if theta is the smallest positive value, are given by theta and pi minus theta. Okay, that was one. This works whether theta is less than 180 or more than 180 degrees. Okay. And sometimes if theta is more than 180 degrees, that pi minus theta might end up becoming a negative value, which is fine. That's the negative angle. But the solution is true. Okay. And I'm not sure if I highlighted this at different points in the previous video, but if you did not like make a separate note of it, I would ask you to do it now. These are like important stuffs you might want to keep in your cheat sheet, even for exams. Okay. And if cos x equals cos theta, similarly, okay, the two solutions, basic solutions that you get will be plus minus theta. As simple as that. You can also say 2 pi minus theta. The minus theta can be is same as 2 pi minus theta. But for simplicity, I will leave it as plus minus theta. Okay. And if finally, okay, if tan x equals tan theta. Again, theta being a known like small angle. I think I need to move to the left here. If tan x equals tan theta, then your x is theta, and remember tan is periodic with pi. That just helps here. Okay, x will be theta and pi plus theta. Again, all of these solutions work with every whether theta is in first quadrant, second quadrant, third quadrant, fourth quadrant, it works for all. Okay, so these three basic results you want to make note of. So when we say here in the first paragraph of this lesson now, solve equations with multiple angles using the same techniques as for regular angles, we would be using this. These three are going to be the almost towards the end, the one of the last steps in that solution. And then because these are multiple angles, on the left side you would not be having x, you will be having 2x or 3x or half x, right? That last part you take care simply by multiplying by that number on the other side. Okay, like the normal arithmetic way. Okay, let us do some examples, it will be more clear. Find all real solutions for that equation. Okay, when it asks all real solutions, you write the general solution. Okay, and this unit circle diagrams I will use for reference to remind us how to get the value of the angle. Okay, 2 cos 2x equals negative root 2. So cos 2x is equal to negative root 2 divided by 2, right? Divided by 2 on both sides. And now you have to think what is the smallest positive angle which gives you negative root 2 over 2, or the angle in the unit circle, and then you recollect the coordinates in the unit circle. That's where you have negative root 2 over 2, root 2 over 2. That is multiples of pi over 4. 1, 2, 3. Okay. And cosine is x coordinate, right? So that is cos 3 pi over. Okay. And now remember what that means. That means 2x is equal to plus and minus 3 pi over 4. Those will be the basic solutions. And if I have to write all real number solutions, I say plus 2k pi. Right? You can add multiples of 2 pi. And we need to get to x. So to get to x, now divide both sides by 2. That will become, now I'm going to write the 2k pi first. Okay, it looks more neater. 2k pi divided by 2 will be k pi plus minus 3 pi over 8. 3 pi over 4 divided by 2. The 4 and 2 will multiply, where k is any integer. Okay. All real solutions. You can always go ahead and give it a try. Sin x over 3 plus 1 equals 0. So I will say sine x over 3 equals -1. Okay. Then you look at the unit circle. This is x-axis and y-axis. Where do I get -1? For the y coordinate, because sine x is y coordinate, right? And the logic with sine x for any angle was the graphical, visual wave. I said theta and pi minus theta above. Okay, here, I said theta and pi minus theta. But -1, 1, 0, these are special angles. Okay, you sometimes don't get two different answers because uh, special things happen. For example, here, okay, if the blue one that I'm drawing here was any theta, the other solution would be here, right? Because after all, sine of an angle is the y coordinate. So you get the same y coordinate if you move horizontally across. We discussed this in the previous lesson. But in the case of -1, if you move horizontally, you are still there, right? That is one point of contact for that horizontal line. Okay. So you get only one angle here, and you can clearly see. If you write anti-clockwise, that is 3 pi over 2. Okay. And if you what I want to highlight to you here is this. Okay, I said earlier, the two solutions would be theta and pi minus theta. Now here your angle is 3 pi over 2, theta is 3 pi over 2. So if you do pi minus 3 pi over 2, you will get minus pi over 2, which is the same angle, minus pi over 2, right? So it works. It's not that this two solution, the theta and pi minus theta still works even for this angle. Okay, just that they will be the same. Okay, so sine x over 3 equals sine 3 pi over 2, and that gives you x over 3 equals 3 pi over 2. Then what? Periodicity, right? Plus 2k pi. We are writing all general solutions, all possible solutions. Now you multiply by 3 throughout to get x. This will be 9 pi over 2 plus 6k pi. Okay. There are two ways you can leave it. You can leave it at this. Okay. I will box this as a solution where k is any integer. We will write that. Or you can also do one step of simplification. Okay. Which is that 9 pi over 2 is like 4.5 pi. Okay. I will write it on the right side here. 9 pi over 2 is equivalent to. Okay. Okay. First let me write equal to 4.5 pi. Then that is equivalent to, that has two things, right? Or still let me write two ways. 4 pi plus zero point 0.5 pi. Okay. Which is equivalent to 0.5 pi. Because 2 pi. 4 pi is 2 pi and 2 pi back to 0. So you could write this solution as pi over 2. Like 0.5 pi is pi over 2 plus 6k pi. Can I? In just a second. If I take k, different values of k. Oh, no. 6k plus 4 pi. Okay. Sorry, I abandoned the idea. Okay. It would be more complicated. There is a way to write it, but it will involve more complications. So let's leave it. Okay. What we got. Okay. I was trying to, you know, see if we could make it more condensed, but no, that what I'm trying to do will involve making this 6k pi a little bit more complicated. It's not worth. Okay. All right. Moving on. A tangent equation now. Tan pi x over 4 equals 1. Can go to the unit circle and the coordinates here are 2 over 2, 2, 2, right? And tan is y over x. That's where it is 1. And that is 1 pi over. Okay. So tan pi x over 4 equals tan pi over. And the solution for tangent is one of the simplest one. Pi x over 4 is equal to now pi over 4 plus k, right? Periodicity with pi, and that gives you, now you have to multiply by 4 over pi on both sides. I will show this step. Okay. So you multiply by 4 over pi. So every term, right? Both sides is multiplied by 4 over pi, and you get x equals 1 plus 4k. Turns out to be very interesting solution. Okay. K is any integer. All right. And so the solutions here are integers of the type 4k plus 1. So that could be like 1, 5, 9, and so on. Okay. On the positive side, and you can go on the negative side. If you want, you can make that list as well. All the way from negative infinity, negative 7, negative 3, 1, 5, 9. These are the solutions. And why is that the case? Because the angle itself has been multiplied by pi over 4 here. Okay. That's why the pi was cancelled on both sides. Okay. Now, if you have to solve equations that involve sec x, cos x, and tan x, you would first rewrite them in terms of cos x, sin x, and tan x, in the respective order. Okay. We will use that idea in the next solution, and also another concept. In the previous set of problems, we were asked to write all real solutions. So we wrote in general in terms of k pi using the ar- arbitrary integer k. Now we are asked to give solutions in this interval 0 to 2 pi. Okay. And I want here you to make note, these are the two types of instructions you will get typically in a problem asking you to solve a trigonometric equation. Okay. What are the two types? Write general solutions, which is also called all possible solutions, all real solutions. That is one type. The second type is write solutions in this range. Okay, and that range typically is from 0 to 360 degree, because it makes sense. That will be one full round of angles. Okay, from starting with x-axis back to x-axis, and you will see that that is why even the 2 pi is not included, because that is same as 0, right? So if you include 2 pi, you are repeating 0 and 2 pi, they are equivalent as angles. So you put parenthesis there. So just up to 359.9999 degrees. Okay, so in that range between 0 and that, what are the solutions? So in a way, you are trying to get the values entirely different, you know. And after that, all you're doing is repeating those same values in a periodic way. Okay, so how do we do it? Both these things are happening in this problem. Converting cosec x to sin x, we will do that, and also we will write those solutions. Okay, in that interval. Now follow me step by step. First of all, isolate this cosec, so it will be easy to convert. If cosec alpha is 5, cosec 5 alpha is -2, you can say sine of 5 alpha is negative half, a reciprocal, right? And negative half for sine, where does that happen? Sine is positive in first, second quadrant, negative in the third and fourth quadrant. So you will want to go down here. Okay. So you can write that angle as, if you want to write, in a positive way, you will go counterclockwise, and that would be your 11 pi over 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And then we said that, you get the same angle if you travel horizontally to the other end. And that angle you can count again anti-clockwise is going to be 1, 2, 3, 4, 5, 6, 7. Okay. So because of that, we say 5 alpha is equal to 11 pi over 6 or 7 pi over 6. Right? Okay. That's what we do for sine. And if you want, again, I will say you can use this theta and pi minus theta logic. Theta and pi minus theta. Okay. Theta is 11 pi over 6. If you do pi minus 11 pi over 6, you get negative 5 pi over 6, which is same as 7 pi over 6 when you add 2 pi to it, or when you convert it to positive. If you go clockwise, that 7 pi over 6 is negative 5 pi over 6. Okay. So writing in positive values, these are the two basic solutions. But why did I write them in a separate line? There is a reason. See, we have to get the values of alpha between 0 and 2 pi. What we have here is the values of 5 alpha between 0 and 2 pi. Okay, that's not enough. As you will see, if 11 pi over 6 is one of them, the another equivalent value you can get if you add 2 pi. Okay, that will be 11 pi plus 12 pi over 6. When you make the common denominator, that 2 pi you do 6 over 6, so it becomes 12 pi over 6, and you add them. So that basically means If you add 12 pi in the numerator, you'll get another angle equivalent to that, right? 23 pi over 6. Now that is definitely more than 2 pi. 23 over 6 is 3 point, almost 4 pi. But why am I considering it? Because I have to divide by 5. Okay. And now you can do a quick calculation in your head. If you divide by 5, you are going to get 30 in the denominator. There is already a 6 on the right side. Okay. You divide by 5, it becomes 30. 6 times 5, 30. So in the numerator, you can go up to 60 pi. 60 pi over 30. I'm writing here on the bottom side. 60 pi over 30 is 2 pi, right? So that will be your threshold. Okay. So next is 35 pi over 6. And I explained that here. There are many things going on here. You have to be continuously watching and tracking. Okay. Why do I say another value is 35 pi? Because we learned here that adding 2 pi is basically adding 12 pi to the numerator because there is divided by 6. Okay. So 11 pi plus 12 pi over 6. Then that 23 pi plus 12 pi over 6. And I have to continue this until I reach where 60 pi. So I'm going to erase this in a for the time being. I'll come back to it again. Next value would be 47 pi over 6. Then 59 pi over 6. I'm just adding 12 pi, 12 pi, 12 pi, the numerator. Okay. And then we start with the next chain, which is 7 pi over 6. And then 19 pi over 6. And 31 pi over 6. And 43 pi over 6. And 55 pi. Okay. These are all valid solutions. We have to write the alpha now. Alpha will be, now you divide by 5 on both sides. Each of them will become basically, I'm going to now write them in a set. Okay, those are the exact list of values. And you can write in ascending order if you want. Okay, looks like the smallest is 7 pi here. So 7 pi over 30. Then I get 11 pi, 11 pi over 30. Then I have 19 pi. It is alternating between the two lists. Okay. And then if you go up, you get 23 pi over 30. Then here you have 31 pi over 30. Then 35. Here 43. And then 47. Okay, at this point I need to decrease the size of my font. Okay, otherwise I won't be able to fit them in. 47 pi over 30. We are almost done. Then we have 55 and 59. Close the set. Okay, those will be your solutions. All right. Sometimes it can be lengthy. Okay, and it happened because we had 5 alpha. So we had to go all the way up to 60 pi over 30. So that finally the alpha is between 0 and 2 pi. Okay. 59 pi over 30 is almost 2 pi. The next value would be above 2 pi. one more example. This time you are dividing by 2. Okay, you can go ahead and give it your try. Where does root 2 happen? Okay, in the unit circle. Now, if you know already, you can directly write in terms of sec also, but no, we do it in terms of cos because that's we memorize often. Okay, so here you would say cos alpha over 2 is equal to 1 over root, the reciprocal. Okay, and that is the same as root 2 over 2, and we know the corresponding angle is pi over 4. Okay, pi over 4, the first one. Then for cosine, the solutions are plus minus, right? Plus pi over 4 and minus pi over 4. They will have the same cosine value. But instead of writing minus pi over 4, I'm going to count 1, 2, 3, 4, 5, 6, 7. Right? That's 7 pi over. So I will say alpha over 2 is equal to pi over 4 and 7 pi over 4 to begin with. Okay. But unlike the previous case where you had to include more angles, here in fact you might have to include less angles, okay? Because you have alpha divided by 2. And if you try to solve here, you get alpha, you multiply by 2 throughout, you get pi over 2 and 7 pi over 2. Now that 7 pi over 2 is more than 2 pi. That's like 3.5 pi. Okay, greater than 2 pi. Equal or greater than, you can say, no? Because if it is equal or greater than 2 pi, you can discard it. Because we are asked to write solutions in the interval 0 to 2 pi. Okay. So your answer here is this. Therefore, the only solution you have to include is pi over. Okay. In multiple angles, if the angle itself has been divided, you will get less number of solutions. Okay. Now for this problem, first you will have to use the calculator because the value is not a standard angle. But other than that, the logic is the same. Okay. It is a basic sine equation. So you know, once you know the smallest theta, the other angle will be pi minus theta between 0 and 360. But then you have to multiply by 2 and see if they still remain less than 360 degree, you know, and only those which fit in 0 and 360 would be your solutions. So two things. Firstly, use calculator and make sure that it is in degree mode. Okay. And this is not going to help now. Okay. Because that's not a standard angle. So sine alpha over 2 will be equal to um, sine, I will write the angle by using the calculator. Okay. Okay. So like this, you should do in your calculator. Check on the top row that it is in the degree mode and sine inverse of 0.47. Okay. It's 28.03 degree. I'm going to go with that. 28.03. Okay. degree. So you can say alpha over 2 is equal to 28.03 degree. And what's the other angle? 180 degree minus theta. Okay, if theta is in degrees. So 180 minus 28 over 28.03 will be 1 oh, uh, 28, right? 151.97 degree. Okay, those will be the two angles. And let's see what alpha will be here. Multiply by 2, get 56.06 degree, and 302. Not 2, it will be more than that. 303 it will be. Okay, point. 303 point. I guess it will be 94. You can check on your calculator. But both of them are between 0 and 360. And I can be guaranteed there's not one more. Okay. In that range 0 to 360, these are the solutions. What if I had taken another circle with 2 pi, then it will go beyond 360. Okay. So these are the answers. All right. Find all real number solutions to the nearest 100. Now, it is again asking us back to writing all general solutions, but it says nearest 100 because what you are going to see here is not going to be an standard angle. Let us try. Okay, what do we get? I have to solve. I'll isolate the cot first. Cot negative cot pi x minus 2 is equal to negative 4. Take the 4 to the other side. Both sides are minus. You cancel them. Okay, I just do that mentally. And I need to convert in terms of tan. Okay, for convenience, tan pi x minus 2 will be equal to 1 over. Right? So what you do again? Use the calculator. Now you need to do tan inverse of 1 over 4. Okay. And the question doesn't say write in degrees. So you write in radians. Okay. It is by default. Remember, radians mode is the default mode. Okay. If you are not given the particular measure, always write your solutions in radians. Okay. Now keep your calculator in the radian mode and compute tan inverse of 1 over. Okay, so in radians, the value was 0.24 radians, 0.2355, and our nearest 100. Okay, so that will be 0.24, rounded to 2 decimal places. Okay, so that gives you pi x minus 2 is equal to 0.24, and for all real solutions with tangent, we write plus k pi. Okay. There is still some more work to do because I have to solve for x. Pi x will be, take that minus 2 to the other side and add, it will be 2.24 plus k pi, and then divide by pi on both sides. So it will be 2.24 divided by pi plus k. Actually at this point I am reminded of one thing I used to tell you earlier. Okay, let us not round off to 2 decimal places here. Okay, you can do two things. Either you can leave it as tan inverse 1 over 4, so you can do the final calculation, which is much recommended. But since I already wrote it, I'm just going to balance. I'm going to manage with what I have written. Okay. But what I will do is, instead of rounding to two decimal places, I will take four decimal places. It was 2355 on the calculator. Okay. I'm still going with that, so that in this step, now when I divide by pi, I will get the um, then I can round up to two decimal places correctly. Okay. And that would be my solution. X equals whatever I get there plus k, where k is any integer. Okay, those will be my solutions. And now I'm going to use a calculator and plug in that value. 0.07. Okay, 0.07 plus k. All right. Next, I'm going to talk about this technique, called intersection of graphs to solve. See, solving trigonometric equations analytically is fun, okay? But oftentimes, your equations could be quite complicated and difficult to solve analytically, right? And especially if it has two different trigonometric functions like sine 2x equals cos x. Now, if you have to solve it in the analytic way, you have to either express cos in terms of sine. There are techniques. It's possible, but this particular equation is doable, okay? But another equation like that, if it had cos square x, let's say, and then or cos cube x, it would be difficult, right? So this other method is to go the graphical way. Okay. And what we do in that is, you take that equation and first bring everything to the left side so you can define a function. Okay. You write it as sine 2x minus cos x equals 0. Okay. And then you let that left side to be the function. Let f of x be that function. Sine 2x minus cos x. Now, that equation sine 2x minus cos x equal to 0 is basically f of x equal to 0, right? So, for any function f of x, if I graph it, what are the solutions of f of x equal to 0? Those are the points on the x-axis, right? Those are the x-intercepts. Then what we do is, you see here the diagram, that is the graph of the function f of x. Okay, I'm going to write here on the left side. That's the graph of the function f of x. And I have used Desmos graphing calculator to generate this. You can use one such online tool or a graphing calculator. And in that, I noted down the x-intercepts. Okay. In most of the tools, it will be easy. Either there should be some way to specify, give me the intersections with the x-axis, or if you are able to use a cursor, you can click on those points and write the coordinates. Okay. And I found this. I will circle them. Pi over 6, 5 pi over 6. Okay. They don't line up in the lines because the unit was, I think, 1, 2, 3 on the grid. Okay. So what you're seeing here is, no, not pi over 2, pi over 2. Sorry, the black one was pi over 2. Actually, you can see the color and the color of the point and the uh, level for it. Okay. So the second one was pi over 2, then 5 pi over 6, then 3 pi over 2. Okay. I stop there. Why? I have drawn here this vertical line at 2 pi. Okay. And I'm to write solutions between 0 and 2 pi. Right? Okay. Suppose, if you have to write between 0 and 2 pi, I'm not saying you have to. Um, then this will be the solution. Pi over 6, pi over 6, pi over 2, 3 pi over 2, and that's it. 13 pi over 6 is more than 2 pi. Uh, and this 0 minus 1 is not a solution because that's not on the x-axis. We have to look for points on the x-axis. Okay, that is the y-intercept, but not a solution to the equation. All right. So I'm going to write here solutions in this 0 to 2 pi range. Okay, will be pi over 6, pi over 2, pi over 6, and 3 pi over. Okay, and here's a opportunity for you to practice. Okay, I will ask you to do it. I'm not going to do it. Use any graphing tool that you have. As I said, you can use Desmos or a graphing calculator. What you do is on that tool, plot the function, bring that to the left side and plot tan 3x minus cot x over 4. Okay. And then try to look for the uh, points on the x-axis where that graph intersects. And if you look in the range 0 to 2 pi, you will find these answers. Okay. And these are very interesting. You can see they all increase by 4 pi. Okay, starting by 2 pi over 13 plus 4 pi plus 4 pi plus 4 pi until you hit 26 pi over 13, which is 2 pi. Now, if you are not including 2 pi, you can exclude that and write only the values before that. But I would recommend you include it because this is same as 0, right? The 2 pi is same as 0. So that is also a solution. Or not. 0 a solution here? No, 0 is not a solution, but 2 pi is a solution. This is interesting. Okay. In what sense? If you plug in 0, you will get, if you plug in 0, you get tan 0 equals cot 0, which is not true. Cot 0 is infinity. Okay, undefined. But if you plug in 2 pi, okay, then you have tan 6 pi on the left. This is interesting. Okay, which is 0. After all, that's 2 pi, 2 pi, 2 pi, tan 6 pi 0. On the right side, you get cot 2, 2 pi over 4 will be pi over 2, right? And cot 90 degrees is also 0. So 2 pi will be a real number solution here. So you should include it, I would say, no, but not 0. Okay, very interesting. All right. So maybe, that's like one difference between 0 and 2 pi you are seeing here. We have been saying, that 0 is equivalent to 2 pi, but in certain equations, they might play a different role. Okay, so here you can say 2 pi is a solution, but you cannot say 0 is a solution. All right. Okay. Here is a word problem. If you were accused of firing and M16 into the air and breaking a window 4,000 feet away. Okay, what would be your defense? You want to claim that you didn't do it. Use this information. The velocity of that bullet fired from M16 is given there. The distance in feet traveled by the projectile fired at angle is given by this formula. Okay, so let us see if we can fire M16 from 4,000 feet away and break the window. Okay, so in this equation, what are the things? The velocity v0, which is given 4,000 feet. The distance is given and sine 2 theta. We'll solve for theta here. Okay, so 325 squared sine 2 theta equals 32 times 4,000. Okay, so what does that give you? Sine 2 theta will be equal to 32 times 4,000 divided by 320, 325 squared. We need to put that in a calculator and evaluate. That's the first thing. Okay. Okay. You get this. 1.2118 and some more decimals. But that's it. We're done here because what do we get? Sine 2 theta is more than 1. Remember, that's not the range of sine. Sine can take values only between -1 and 1. Okay. And that is your defense. So what you're saying is wrong because of this formula. And if I did fire the M16, doesn't make sense because I get sine theta more than 1.2, which cannot be the more than 1, which cannot be the case. Okay? It's not possible. This is greater than 1. That's not possible. Okay. With that, we're done with this lesson. Thank you for watching. I'll see you in the next video.